Question. Study the graph in figure 14. So this is a velocity time graph. A. Determine the average acceleration for the entire trip. B. Determine the instantaneous acceleration at 3 seconds, 6 seconds, and 9 seconds. C. Sketch a qualitative acceleration time graph of the motion. A. The average acceleration equals the change of the velocity divided by the time interval for the change, and this equals the change of velocity equals the final velocity minus the initial velocity, and the time interval equals the final time minus the initial time, and this equals, look at the picture, the final velocity here is 0. So final velocity is 0 meter per second minus the initial velocity is here, it's 50. So here is 50 meter per second forward. And for the time, look at here. The final time is 10 seconds. And minus the initial time is 0 seconds. 0 seconds. And this equals negative 5 meter per second square forward. And equals 5 meter per second square backward. And B. The instantaneous acceleration at a time point equals the slope of the velocity time graph at that time point. And the slope of the velocity time graph at a time point equals the slope of the tangent line at that time point. I just show how to find the instantaneous acceleration at 6 seconds. And the way to find the instantaneous acceleration at 3 seconds and 9 seconds are the same. So for the 6 seconds, I already draw the tangent line at 6 seconds. The acceleration at 6 seconds equals the slope of the tangent line at 6 seconds. And to find the slope of this tangent line, look at here. At the left end, its velocity is around 8 meter per second forward. And minus at the left hand, the velocity is 50 meter per second forward. For the time at the right hand, the time is 10 seconds minus at the left hand, the time is around 3 seconds. So here is 3 seconds. And this equals negative 6 meter per second square forward. And this equals 6 meter per second square backward. So this is the instantaneous acceleration at 6 seconds. The way to find the instantaneous acceleration at 3 seconds and 9 seconds are the same. Now, question C. Sketch a qualitative acceleration time graph of the motion. So here, the vertical axis is the acceleration, and its unit is meter per second square, and backward. And the horizontal axis is the time. So time, its unit is seconds. And here is 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Here is 0. And for the acceleration, here is 5 meter per second square. Here is 10. Here is 15. And check the velocity time graph at time 0. The slope of the velocity time graph is 0. So at time 0, the acceleration is 0. So it's here. And we already found that at 6 seconds, the acceleration is 6 meter per second square backward. So at 6 seconds, its acceleration is around here. I did not calculate the acceleration at 3 seconds and 9 seconds. I just assume that at 3 seconds, the acceleration is here. And at 9 seconds, the acceleration is here. And I just use a smooth line to connect these dots to draw the qualitative acceleration time graph.